In this video, I want to talk about sum to product formulas. We've already looked at the product to sum formulas where, and I have them here, we've got a product on one side and a sum on the other. The thing about the product to sum formulas is that on the product side, the angles are simple. On the sum side, the angles are more complicated. Okay. Now I have it written, I have each of the four of them written this way. With the 2 on this side because I'm going to end up with, I want to just have a sum by itself and I'm going to end up with the product and the 2 over on this side. Okay, so these are not the sum to product formulas. These are the ones we've already done. These are the product to sum formulas. Now what we want to do is we want to say each one of these, I just want to rewrite it so that the angle over here, these angles are simple, and over there they're more complicated. So what I'm going to do, I'm going to just take that first one and I'm going to say I want to think of this like this. I've got 2 times the sine of something times the cosine of something equals the sine of, well, I'm just going to put a u here and something else, so I'm going to be the sine of, let's say, v right there. So instead of an a plus b, I want just a simple u, just a single variable. Likewise here, a minus b, just some other variable. And now I got to figure out what goes in here. It's the same relationship. I'm not making a new identity. I'm just talking about the angles differently. So what's happening here is u is playing the role of a plus b. All right? V is playing the role of a minus b. What I need to do now is figure out what plays the role of b by itself. What plays the role of a by itself. Okay? So this is just the same identity here, except I'm trying to make the angles on this side be simple and see what they have to be on that side. Okay. Well, here I have a couple of equations here, and let me just solve for a and b and see what has, a is what has to go in here. So what does a equal? B has to go in there. So what is, well, first thing I see to do is add these equations. Look at this. If I add the left-hand sides, this is u plus v. If I add the right-hand sides, I get 2a. That tells me that a has to be u plus v over 2, and that's what I'm going to stick right in there in the spot of a, u plus v divided by 2. Likewise, if I were to have subtracted these two, if I said u minus v, then this one minus that one, the a's would go away and I'd have b minus negative b. That would be 2b, or would it be not 2b? Oh, that's always my question. I think it's 2b in this case. Solve for b, it's u minus v over 2. And that's what I'm going to plug in right here, u minus v over 2. So right there, this identity, yay, put stars around it, is my first sum to product identity. It's equivalent to that first product to sum identity, except that the angles on the sum side are now the simple angles, and the angles on the product side are the more complicated ones. But the relationship is still the same. If I take this plus that, I should get this first angle, right? If I take u plus v over 2 and I add u minus v over 2, the plus v and the minus v are going to go away. You got a 2u over 2, which is u, right? You add them up, you're going to get u. You subtract them, you're going to get v. This relationship is the same as that one, except that the angles here are nice, the angles there are complicated. Likewise, the same substitution now works in all of them. So every place I see a u plus v, what is that? An a plus b, I'm going to stick a u in. Every place I see an a minus b, I'm going to stick a v in. And a and b are going to be correspondingly substituted for. So let me see here. The second identity there, if I just get it on the screen, I think I can just rewrite it here. I've got 2 times the cosine of a, but a is being replaced by u plus v over 2, times the sine of b, but b is being replaced by u minus v over 2, is equal to sine of u plus, no, minus this time, sine of v. So if I have a sum of 2 sines, I can turn it into this product. If I have a difference of 2 sines, I can turn it into that product. Let's keep going. Let's keep going, because the next one says 2 times the cosine of u plus v over 2 times the sine of u minus v over 2 equals the cosine of u plus the cosine of v. So when I have a sum of two cosines, I can write it as a product of... Did I not copy that right? That's a cosine, isn't it? You're probably sitting there thinking, Will, you're not paying attention. That's cosine, cosine, so let's put a cosine, cosine right there. Yeah, sum of two cosines turns into a product of two different cosines. And lastly, we've got this one, where this is going to be a cosine u minus cosine v, and it's going to turn into negative 2 times the sine of u plus v over 2 times the sine of u minus v over 2. So the product to sum formulas turn into the sum to product formulas simply by saying, where do I want my simple angles? In the sum or in the product? When they're in the sum, you've got the sum to product formulas. When their simple angles are in the product side, it's product to sum formulas. Okay, 4 of each. There you go.